Hello learners, welcome to the another session on measures of central tendency. In this session, we are going to talk about calculation part, how do we calculate mean, median, mode. As you have studied well about the concept of all these three things in the previous sessions, in which we discuss the properties of mean, properties of median as well as properties of mode. We also discuss about advantage and disadvantage of mean, median, mode. We have also covered that on what ground you can select mean, median, mode for your data set for the measure of central tendency. In this session, we are mostly focused upon the calculation part. How do we go for the calculation of mean, median, mode for the two different type of data set. One is called group data and another one is called ungrouped data. Let me talk about what actually ungrouped data is all about. Although you might be aware about this term, but let me discuss about it, what ungrouped data is all about. So the word itself enough to understand what ungrouped means. So any data that has not been categorized in any way, it is termed as an ungrouped data. So if you are not categorizing any data in any group, then the data set would comes under the ungrouped data. For example, if there are three observation of the age of the individual, like one individual is belong to 25 year of old, the second one is 30 years and third one has 50 years. All these three different age person is basically considered as ungrouped data set. Whereas for the group data, a data that is categorized or organized in terms of the group data, or mainly such as the data is organized in the frequency distribution that you have understand in the previous sessions as well. So when we organize the data in the frequency distribution or we categorize into different categories, then it comes under the group data. For example, in the previous example we have seen that for ungrouped we have a three different age group, but for the group data you can have a range like 26 to 30 years of age, 31 to 35 year of age, 36 to 40 year of age and so on. So all these three comes under the group data. So when we go for the computation of mean for ungrouped data, there is a simple formula that you are aware that how do you calculate the average of any data set. So similarly we calculate mean of the data set for ungrouped data. So you can see in the screen that the formula of ungrouped data is m is equal to summation of capital X divided by n, whereas capital X means the score itself, the individual score of the data set, n is the total number of data set, whereas capital M indicates that the mean of the data set, and summation x means the summation of sum of all the scores in the distribution. With the help of all these three things, we calculate mean of the data set. Let me give you one example through which you can understand how do we calculate the mean of ungrouped data. You can see on the screen that there is a data set which is a score obtained by the 10 students in the psychology test as given in the screen, like 58, 34, 32, so on. So how do we calculate the mean with the help of previous formula that I have discussed with this ungrouped data set? There are certain steps that you need to follow. Very first step, that the first step in order to obtain the mean for the above data that we have discussed, we will first add the marks that obtained by each individuals. So which is called summation capital X. You can see on the screen that the marks has been added like 58 plus 34 plus 32 plus 47 so on, and you can see after adding all these scores we got 450 as a whole scores. In the step 2, now we have to use the formula. We will compute the mean with the help of formula summation capital X divided by n, where the n is the total number of data. So here we have total number of data which is 10. The 10 students have scored different in the psychology test. So we have 10 data. So n is equal to 10 and summation X we have calculated which is 450. So by applying the formula mean is equal to summation X divided by n, we can get the score 450 divided by 10 is equal to 45. So the mean with the help of formula that we have discussed which is 45 for the ungrouped data, and the formula is summation x divided by n. So thus the mean obtained for the data which is called 45, and how it has been calculated with the help of formula summation x divided by n. So let me talk about the calculation of mean for group data. How do we calculate mean with the help of group data? We can have one formula for the calculation of group data. Here in the group data, you will see the range of a score as well as the frequency of a score. So there is a slightly change in the formula, and the formula is almost same as the ungrouped data formula, but here we use the frequency f is multiplied by each score and divided by n. So m is equal to summation fx, where the f is small f is indicating the frequency of the data, and the x is the number of midpoint and divided by n. So summation capital X is the midpoint of the distribution, frequency small f is the frequency, repeated frequency, and is similar the total number of score. Let me give you one example through which you can understand how do we use this formula for the calculation of mean. A class of 30 students were given a psychology test, and the marks obtained by them were categorized into 6 categories, and because it is group, then we can categorize into categories. The lowest marks obtained by some individual, which is 10, the highest marks was obtained by someone is 35. The class interval of the categorization is 5, which was employed, and we have formed the tabulation. We have tabulated the data in such a way, you can see on the screen the minimum score is 10, whereas the maximum score is 39. So you can see the tabulation is like this, the frequency the class interval is like this. In the very first column, you can see from the left, you can see the class interval 10 to 14, 15 to 19, 20 to 24, and so on. You can see 35 to 39. In the second column, we have a frequency of the data. Then we have calculated midpoint, because in the formula we required there is a requirement of midpoint. And how do we calculate the midpoint? Of course, we calculate the midpoint by adding the minimum score and the maximum score of the class interval divided by 2. For example, for the first class interval 10 to 14, we will have midpoint 12. How we can calculate? 10 plus 14 divided by 2, which is 12. You can see the very first class interval, the midpoint is 12, and the next column we have written fx. F is the frequency and x capital is the midpoint of the score. So similarly, in the first from the bottom, you can see the very first class interval, which is 10 to 14, which has 3 is the frequency, 12 is the midpoint, and when we multiply 3 into 12, we can get fx score, which is 36. So let me go step by step through which you can calculate further about mean with the help of formula that we have discussed just before. So the very first step is to arrange the data in a tabular form, where the marks can be grouped into the category, and the class interval can be, you can take 5, 4, it's depend upon the how you are making your frequency distribution. In the step 2, once you categorize the data and you have created the different class interval, the marks are given to the different class interval, and the frequency which is there, you can easily make the categories, and accordingly you can give the frequency of the class interval. Then the third point, we have to, in the very third step, we calculate the midpoint. And how do we calculate? We add initial, or we can say the minimum score of the class interval plus maximum score of the class interval divided by 2. In the first case, we calculated 10 plus 14 divided by 2 is equal to 12. Similarly, for others you can see in the same way. In the fourth step, we calculate fx score. We multiply frequency into 4 with the midpoint of the score, and we calculate fx is the actual score. So in the fourth step, we have to calculate fx. In the fifth step, we have to sum up all fx score, that is indicated in the very bottom row of the last column, and you can see summation of fx is equal to 780. In the sixth step, what we use? We use the formula which has m is equal to summation fx divided by n, and we put all the value here and we can get the score of mean. So, for calculation of mean is equal to fx, summation of fx is equal, we got 780 and divided by total number of data, which is the total number of frequency itself. So, n is equal to total number of frequency, which is 30 here. So, we can calculate mean is equal to 780 divided by 30, which is 26. So, for this data, for this group data, we have calculated mean with the help of formula which is summation fx divided by n, and we got a score which is 26. Let me talk about another way through which we also calculate the mean, which is also known as shortcut method of calculation of mean. When we sometime it is very useful when we have a very large data set, then we can go for the shortcut method, and which is also known as assumed mean method. So, in certain cases when we have a very large data and it is not possible to compute fx which we have calculated just before, in such situation we can use a shortcut method with the help of assumed mean can be computed. So, what is the formula of calculation of mean with the help of shortcut method? Which is the formula is, you can see in the screen, which is m is equal to am, which is assumed mean, plus within bracket summation fx bar divided by n xi. Let me discuss all of the symbols what we have used in this formula. Am is stand for assumed mean, whereas the summation symbol is for summation only. I is the class interval, small I is the class interval. X bar is the difference of score x minus am divided by I is the x bar. X is the midpoint of the score in the interval. F is the frequency of the scores, and n is the total number of frequency of the students or frequency of the score. So, total number of a score is n, f is the frequency of a score, x bar. How do we calculate x bar? Of course, with the help of x minus am divided by I. So, let me give you one example through which you can understand. See on the screen, there is a table, and in this table you can see the previous calculation that we have done with the same table and with the same distribution. Now, by using the same example, we are going to calculate the mean with the help of assumed mean or shortcut method. The very first step, we will assume first the mean. So, how we can assume the mean? It's depend upon you. You can take a middle point of the distribution. So, here I am taking the mean, assumed mean is 22. So, you can see the assumed mean 22 is lying in the class interval 20 to 24, which is the midpoint of the class interval of 20 to 24. So, we are assuming, you can assume 27 as well, you can assume 17 as well, but generally we assume at the middle of the distribution. So, let me take this example with the assumed mean is 22. The second step, we differences is obtained between each of the midpoint and assumed mean, and then the same is divided by I. So, you can see in the first, second and third, in the fourth column. In the fourth column, you can see which is calculated the second step that we have to calculate, which is the we have to obtain the score, which is the differences is obtained between the each of the midpoint and the assumed mean, and then the same should be divided by the I, which is the class interval, and that is the class interval 5 we have. So, these are then entered under the column with the headings x bar, and the x bar is nothing but it is the x minus am divided by I. So, you can see here for the 22 for the class interval 20 to 24, we have assumed mean 22 and we have x bar is equal to 0. You can calculate accordingly. So, in the step third, what we do, we go for the frequency fx into x bar. We multiply f means the frequency into the x bar that we have calculated, obtained. For the case class interval 20 to 24, we have fx would be 0 because x bar is 0 and f is equal to 6. So, 6 into 0 is equal to 0. Similarly, we do for all the class interval. So, all the fx bar are added to obtain summation of fx bar, because this is the measure input that we have to use for the calculation of mean with the help of a shortcut formula. So, as you can see in this table, we have summation of fx bar is equal to 24. We have added all the scores in such a way that we got 24 for all the class interval. So, summation of x bar is equal to 24, or sometime we say x dash. So, x dash and x bar is sometime we usually interchangeably use. So, mean is equal to am plus summation. Let me use the formula here, and accordingly you can calculate the result. So, mean is equal to assumed mean plus summation of f x bar or x dash, you can say, n into I. So, the am that we have assumed mean we have already assumed, which is 22, and we got fx dash or fx bar is 24 divided by 30 into n is equal to 30 and I is equal to 5 is into 5. So, we can get the score 22 plus 4 is equal to 26. So, after all calculation, you can see the obtained score is 26. And if you can recall that with the proper method, we also got the same score for the mean, which was 26, and with the help of assumed mean, we also got the same score, which is 26. So, with this you can calculate the mean score with the help of two methods for group data. One is the formula and the another one is we use for the shortcut method with the help of assumed mean. Let me discuss about the computation of median. For first ungroup data, then we will discuss about group data. So, as you know that the mean is nothing but the middle score of the distribution when the distribution is distributed in the arranging has been arranged in the ascending or descending order. For example, you can see in the screen, if you have a data set which is further can be in number of odd data or can have number of even data. Suppose you have 10 data set or you have 9 data set, there would be a different calculation for the median. So, if you have even data, then there is another formula. For odd data, we have another formula. So, let us start with the odd data. So, suppose you have odd data set means your n is odd. So, you can see in the screen we have total number of data set is 9, which is odd. For this, how do we calculate median? So, first we go for the step 1, which is the first data is to be arranged in either in ascending or descending order, it is up to you. When we arrange the data into ascending and descending order, then in the second step what we do, we first identify the position of 50 percentile or middle position. How we can do it? Only by using the formula n plus 1 divided by 2. N plus 1 divided by 2th score would be the position of the median score. For this example, we have n is 9, then the position would be 9 plus 1 divided by 2 is equal to 10 divided by 2 is equal to 5th. So, the 5th term either from right side, from the left side, from top, from bottom would be the median. So, let us go with the data set and see which one is the 5th position of the data. So, if we start counting with the left side, then in the ascending order we have 30, 32, 34, 34, then 35. So, the 5th position we are getting 35 score. From the right side 74, 67, 58, 47, 35. So again from the right side it is also coming, the fifth position is 35, at the fifth position from the left side is also the score is 35. So 35 would be the median of this ungrouped data. If we have even number of data, then the formula would be different. So what we do, all the steps will be almost same. First what we do, for calculation of median for even number of data set, first we arrange into the in the ascending or descending order. First we arrange the data set into the ascending or descending order, then we go for the identifying the position of the median score. For that we go for the formula which is known as n by 2 term plus n by 2 term plus 1 divided by 2. So how do we do it? Let me give you example through which you can understand. So in this example we have total number of data is 10. So n by 2 is equal to 10 by 2, 10 by 2 plus 10 by 2 plus 1. It is 10 by 2 is equal to 5 plus 5 plus 1. So you can see here that n by 2 is the fifth score and which is 35. So you can see here n by 2 score is 35. Then another n by 2 plus 1 position is the sixth position, which is of course 39. So when we divide 35 plus 39, then you will get the median score, divided by 2 you will get the 37 is the median score. Let me explain once again about the step 2. So you have to first identify n by 2th position and n by 2th position. N by 2th position is the fifth and the n by 2th plus 1 position is sixth position. In this case we have total number of data is 10, then the n by 2th position would be 5 and n by 2th plus 1 position would be 5 plus 1 is equal to 6th position score. So here we have 5th position score is 35 and 6th position score is 39. Then the mean would be the 5th position plus 6th position divided by 2 is equal to 35 plus 39 divided by 2 is equal to 37. So the formula is n by 2th position score plus n by 2th plus 1 score position score, and then overall adding of these two score divided by 2. So in this example, 5th position is lying with the 35 score and in the 6th position lying 39 score, then the 35 plus 39 divided by 2 would be the median score, which is 37. Then we have a computation of median for group data, and there is a formula for the group data, and the formula is L plus n by 2 minus f capital divided by fm bracket close into I. You can see the formula on the screen that md is equal to L plus bracket open n by 2 minus f capital divided by fm bracket close into I. Let me discuss about all the symbols. Here L is the lower limit of the median class, n is the total number of score of frequency or total number of frequency, total number of data set you can say, or if you have a group data, total number of frequency. F is the sum of frequency before the median classes. Sum of all the frequency before the median classes is called capital F. Fm is equal to frequency within the interval upon which the median falls. We will discuss more about it, you can understand with the example. So let me here explain once again about the FM. FM is the frequency within the interval upon which the median falls, and the I is equal to class interval. So first of all we identify the median class interval. So let's, with the example you can understand the how do we calculate median for the group data. Let us with the example. In this example you can see there is a class interval of marks of the students who got score in the different things and the frequency. So here the scores are like this, like 10 to 14, 15 to 19, and similarly the frequency is given, which we have used earlier as well, this table. So for the calculation of median, what we do, first the very first step is to identify the median class interval or median group. So, for calculation of median group, we first divide n divided by 2. So, total number of frequency is 30 divided by 2 is equal to 15. So, where the 15 is lying, you can see here the 15th positions means the frequency of course. So, you can calculate and you can see that where is the 15th position. So, 15th position in the case you will see that the class interval coming is 25 to 29 and which is 5. So, the class interval 25 to 29 and the frequency is 5 is the 15th position of the distribution. You can start calculation from the beginning, like class interval 10 to 14 is from 10 to 14 you can start a calculation frequency. 3 plus 4 is 7 plus 6 13 and then we have 5 is equal to 18. So, the 15th position is lying in between the class interval 25 to 29. So, this would be the class interval of median class interval, and with this class interval we will calculate further for the median calculation. So, in the step 2, as the score are even in the number n is equal to 30, the median should fall between the 15th and 16th score, wherever whatever we have added in the frequency from above, which is 5 plus 7 is equal to 17. Either you can come from top or you can go from the bottom, you will get the same median scores. So, from below you can calculate like 3 plus 4 plus 6 plus 5 is equal to 18. So, you can understand how do we calculate the median position. We have just discussed in the previous example with the ungrouped data, and when we have an even number of data, then the frequency would be 15 and 16. So, the 25 to 29 is the class interval which has a median score. So, further L, that is the lower limit of the median class interval, can also be mentioned, as the median is 25 to median class interval is 25 to 29, then the exact lower limit would be the 24.5. Here we take L, capital L is the exact lower limit. For the class interval 25 to 29, the exact lower limit would be 24.5. So, in the third step we compute capital F, that is the sum of the frequency before the median of the class. In our cases, the frequency before the median classes is 3 plus 4 plus 6. So, you can see 3 plus 4 plus 6 value would be the F. So, here F capital is 13. Then we have a calculation of a step 4, which is FM. So, FM is computed, it is the frequency within the interval upon which the median is fall. In the present example, the median class interval is 25 to 29 and the frequency of this class interval is 5. So, the FM would be 5. So, step 5 is nothing but you have to put all the value that you have just identified in your formula of median. So, in the formula of median we have to use L, capital L, which is the exact lower limit score, which we have calculated 24.5, plus n by 2, n is 30 divided by 2, n is the total number of frequency divided by 2, minus capital F, that we have calculated the total below frequency, which is 13, divided by 5 is the actual frequency of the median class interval, and multiply by 5, which is I is equal to also 5. In this distribution we have a class interval is 5. So, with this we can calculate the median score and you can get the median score is 26.5. Thus, the median score we obtained, which is 26.5, and it is fall at again in the median classes, which is 25 into to 29. You can see here whatever the calculation we have done, which is also fall into the same class interval, which is 25 into 29. So, 26.5 is nothing but which is the score which is coming under the class interval 25 to 29, which we have assumed, or not assumed, but we have calculated with the help of frequency distribution ungrouped data positioning process, and we identify that the 25 to 29 is the actual class interval or median class interval, and we finally identify the median score, which is 26.5. Let me come to the another important calculation for the mode, which we discuss about the help of ungrouped data and group data. Here for ungrouped data, you are aware that those data which are frequently occurring can be considered as the mode of the distribution. So let me give you one example. The example is given on your screen. There is a set of data. The mode can be calculated in the simpler manner by just calculating the score that appears the maximum number of times in the data. In our example, the mode would be 34. You can see that 34 is occurring maximum time, and as compared to the other, the 34 is occurring, you can see 1, 2 times, although there is no other score is occurring 2 times. So the maximum occurring score is 34. So thus the mode would be 34 for ungrouped data. Let me give you example for the computation of mode for the group data. What is the formula for the calculation of mode for group data? The formula is very simple. Is mode is equal to 3 median minus 2 mean. So if you have a group data, first calculate the median of the group data and calculate the mean of the group data, that we have discussed earlier, that with the help of calculation of median and mean, we can easily calculate the score of mode. So let me go with the previous one example. Here you can see that there is a frequency distribution and there are certain tabulations. We have calculated the midpoint for the purpose of calculation of mean score and also median. So how do we calculate median and mean? You well aware about it, just we have discussed. So with the help of previous discussion, you can calculate the median and mean of the scores, and further you can use for the mode calculation. So here we have calculated mean is 26.9 and median, which is 24.9, we have already earlier calculated, and we can use these two value for the calculation of mode, which is 3 median minus 2 mean, 3 into 24.5 minus 2 into 26.5, which we will get 19.5. Thus you can see here the mode is 19.5. So in this example that we have discussed just before, you can see we have calculated mean, median, mode for all the measure of central tendency we have calculated for the same score, and how we get the different score in terms of measure of central tendency. So you can see that for mean we got 26.9 score, for median we got 24.5, and for mode we got 19.7. all are different from each other. So if the data set which has a different value of measure of central tendency, like which has different value of mean, median, mode, which indicates the data is not normally distributed. So if the data is normally distributed, then on that cases mean, median, mode score would be almost similar in nature. So with this you can understand how we calculate mean, median, mode of any data set. There is another method through which we also calculate mode, and the formula is L plus D1 divided by D2 plus D2, where the D1 is the difference between the frequency of modal class or class interval below it, and D2 is the difference between the frequency of modal class and class interval above it. So let me give you the example which we have used earlier as well. So you can see in this example, suppose we have to identify the mode, as we generally know that most occurring frequency can be considered as the mode. In this example 30 to 34 we are taking into consideration as a mode, because the maximum number of frequency we can see 7, which is highest among all the frequency. So we are taking 30 to 34 class interval as a mode class interval. For this we have a certain steps that we can use. So we have to majorly calculate D1 and D2. On the basis of D1 and D2, we can easily calculate the mode value. How do we calculate D1? D1 is nothing but the frequency minus frequency minus 1, which is above or below. For D1, let me give you one example. D1 would be 7.5 and D2 would be again 7.5. How D1 and D2 are same? Because you can see the calculation of D1, which is Fm minus Fm minus 1, which is you can see the 7 and 5. So 7 minus 5, below is 5 and above is also 5. In both the cases, you will get 7 minus 5 is equal to 2, D1 is 2 and D2 is also 2, because the frequency we have to differentiate, or we have to subtract with the above with the below, and in our example, below and above are both are the same score, means the 5. So we have to calculate D1. We can calculate D1 is equal to 7 minus 5 and D2 is again 7 minus 5. So in D1 and D2 are same, which is 2. So let me put these two score into the mode value. So in L is the lower limit, which we have already discussed in this class interval 30 to 34. The exact lower limit would be 30 minus 0.5, which is 29.5, plus D1 divided by D1 plus D2. D1 is 2, D1 plus D2 is 4, into multiply by 5, which is I, is a class interval. So the score would be 29 plus 10 divided by 4, 29.5 plus 2.5, which is 32. So you can see the mode formula is very simple, L plus D1, D1 divided by D1 plus D2 into I. So this is the formula. In our cases, we got D1 is equal to 2 and D2 is equal to also 2. So we can put D1 plus D2 is equal to 4, 2 divided by 4 into 5. So the score would be 29.5 plus 2 divided by 4 into 5, and we can get the score 32. So the mode with the another example, with the another process, another formula, we got score which is 32. In the previous, we got different scores. So with this, we can understand how do we calculate mode, median and mean with the help of different formula for the different set of data. If the data is ungrouped, we have a different formula. For the group data, we have a different formula. So I hope you have understand all this calculation, and I wish you should go through the content and you can see the session by revising the scenes, and you can see the formula which is there in between the video, and you can calculate, you can do your exercise with the same formula with the different example which is given into different textbook. You can refer to any textbook which has the same condition you can find, and different examples you will find, and you can calculate mean, median, mode and see whether you are able to calculate the mean, median, mode or not. And I hope you have understand the calculation part, and I think you are now prepared for the further statistical analysis, to know the further statistical analysis in detail. For this, I wish you all the best. Thank you so much.